You've got a 1 kilogram trolley. It's moving at a speed of 2 meters per second. It's at point A on the top of the incline. They give you a height. The trolley rolls down the incline. Obviously, all the potential energy becomes kinetic energy. And then there is a mass that falls onto the trolley. And the thing with this mass that's falling down is in the horizontal direction, it has no velocity at all. It's stationary horizontally. So remember, its total linear momentum is conserved, so they have to be in the same direction. This is not in the same direction. So the first question is, what is the mechanical energy of trolley A? And we land up with EP plus EK, which is equal to a half mv squared. We've been given the mass, we've been given the velocity, plus mg sorry, that's a 0,6, and when I work that out, I land up with 7,88, and we can make that approximately equal to 8 meters per second. Oh, sorry, what have we got? 8 joules. I'm sorry, not meters per second at all. The next part of the question says, what is the velocity of trolley B before the mass falls on the trolley? So now if we have to work out the velocity of trolley B before the mass has fallen onto the trolley, we are going to say that the mechanical energy at the top is equal to the mechanical energy of the trolley at the bottom. And therefore we can say that mechanical energy is conserved. And I can say that this 8 joules is equal to a half mv squared. The mass is 1 and the v I do not know. When I rearrange that and square root it, I land up with 3,97 meters per second, which is pretty darn close to 4 meters per second. And because it is a velocity, I need to put a direction in, so it is to the right. The velocity of the trolley and mass immediately after the trolley has fallen. So now I need to consider that total linear momentum is conserved. And then I'm going to say that the momentum before the collision, now I'm only interested in the collision, so I don't care what happened at the top of the hill. I'm only interested at the bottom of the hill, is equal to, before it was 1 times 3,97, plus, remember I said to you that 0,6 kilograms is going at no velocity in the horizontal direction, so it has no velocity before the collision. Now after the collision, their combined mass is 1,6, and they have some or other new velocity. What is that new velocity? I'm going to need to calculate that out by dividing, and I land up with 2,48, which is as good as anything 2,5, but we'll go 2,48. 48 meters per second. And again, they were asking me for a velocity, so again, I'm going to need to give a direction to the right. They then ask me, was the collision between the trolley and the mass an elastic collision? Support your answer with a calculation. What I'm going to do is I'm going to say that before the collision, EK before was equal to a half mass times, I think it was 3,97 squared, and I land up with 7,88 joules. The EK afterwards is equal to a half. The mass is slightly more, 1,6, and the the velocity is 2,48, and don't forget to square it, and I land up with approximately 5 joules. Therefore, EK not conserved, therefore not elastic. A dynamics trolley of 2 kilograms is traveling at a uniform velocity at 4 meters per second along a horizontal path. We've got a clay lump that's going to fall onto it after the collision. Notice the clay lump has no velocity in the horizontal direction, and the clay lump drops vertically 1,25 meters before it lands on top of the midpoint of the trolley and sticks on it. Calculate the distance that the trolley travels before the clay falls on it. So now we're on to equations of motion. We've got straight motion down of the clay, straight motion across of the trolley. So I am going to say that the distance is equal to, so I'm now just looking at the clay, ut plus a half at squared. My initial velocity is 0. My distance, they've told me, is 1,25 meters. Plus, I have got half, and my acceleration is 9,8, some or other time that it has been in the air. And we can work out how long it took for this to fall down there. And the time works out to be 0,5 seconds. Now, I can say, well, how far did this travel if it was going at 4 meters per second? I'm now at a constant velocity, so I don't use equations of motion. S is equal to Vt. My constant velocity was 40. My time is 0,5. So it must have traveled, 2 meters in the time that it took for the clay to fall down there. The trolley moved 2 meters across to the right. Calculate the velocity of the trolley just after the clay has landed on it. So I'm going to need to talk about the conservation of linear momentum. So we've got total linear momentum being conserved, 2 times 4 beforehand. We've got a mass times velocity. Remember, this has got no velocity at the beginning. Is equal to the combined mass of these two objects. So it's 2 plus 2, which is equal to 4, multiplied by the speed of the object after, no, that's what we're looking for, the speed of the object afterwards. And so I land up with V being equal to 2 meters per second, and because it's positive, it's in the same direction as the 4 meters per second, so it is to the right. We've got a bullet, and we've got a mass of 20 grams. I'm going to convert that into kilograms, so it's going to be 0,02. Hits a wood block 500 millimeters thick. That just tells me how thick the wood block is. Nothing's moved those 500 millimeters at 800 meters per second. It penetrates it, oh my goodness, and it moves on. So it goes through that distance and then goes on and comes out the other side at 300 meters per second. Calculate the loss of kinetic energy experienced by the bullet. So we're going to get the EK before, we're going to work out the EK afterwards, and we're going to subtract. Not difficult, it's a half. We just need to change that mass into a kilograms. 800, don't forget to square the 800, and we've got a half, 0,02, and don't forget to square the 500. No, it's not 500, it comes out the other side, 300, sorry. 300 and squared. And what I find is I get 6,400 joules, and I get 900 joules. And then I'm going to say, so the EK lost in that little trip through a block is equal to 5,500 joules. What force was it that the wood exerted onto the bullet? Well, we know that work done is equal to force times distance. This is the energy transferred. It is the work done by the block on the bullet to slow it down. So it's 5,500 is equal to a force that I do not know in a time which they have. No, sorry, it's through a distance, and that is going to be 0,5 meters. So it's 0,5, and I land up with a force of 11,000 newtons. And they haven't set the magnitude, so I do need to give it a direction against the motion. So the block slowed it down, so it's against the motion. And finally, they ask me the deceleration experienced by the bullet. So F is equal to MA. I have got the force, and it is 11,000. I have got a mass of 0,02, and therefore what was the acceleration? 5,000, oh, sorry. What have I got? It is 550,000 meters per second squared against the motion, or in the opposite direction to the motion.